All right, so we covered the warm-up, number 22. Number 1 says solve x over 2 equals 12 over 3. Number 2, factor by grouping 2x squared plus 7x plus 3. And number 3, solve for y and graph using the domain -2, -1, 0, 1, 2. And the equation given is -4x plus 2y equals 6. Copy that and do that on your own, which we already did, sorry. Our agenda for today, warm up number 22, and we're looking at quadratic equations. We're taking a little side step from where we're at with rationals. And your home play is only 6 problems tonight. Your asynchronous code is IHE5F. IHE5F. Last night's or the previous home play was pages 446, 447. Make sure you turn that into Canvas. And tonight's home play, it's only 6 problems. The first 2, it says solve quadratic equations by graphing square roots and factoring. So you're going to do 3 things to each equation. And the first 2 equations given are x squared minus 100 equals y. And number 2 is y equals 3x squared minus 12. For numbers 3 and 4, it says solve the quadratic equation using square roots. Number 3 reads -3x squared plus 16 equals y. Number 4, -7x squared plus 64 equals y. And for numbers 5 and 6, it says solve each quadratic equation by factoring, and you are given number 5 is x squared plus 7x plus 12 equals y. And number 6, 2x squared plus 5x plus 2 equals y. All right, and our objective for today, I can solve and graph quadratic equations. And if you notice, it's a new concept, and we are going to be solving by graphing square roots and factoring. In your FAIR model, quadratic equations, definition. 2 variable equations where the highest degree is 2. Examples, x squared plus 3x plus 2 equals y, x squared minus 9 equals y, and y equals 3x squared minus 11x plus 6. Now, if you notice on these examples, guys, how many types of variables do you see in each one? Only 2. Look at this first one. We have x and we have y. How many types of variable? 2. Look at this next example, x squared minus 9 equals y, 2 different types of variables, yes. Same on the third example. Highest degree, what are they talking about with highest degree? Well, remember when we did the highest degree that we're like, okay, so for polynomials, I need to check the degree of this one. We add the exponents on the variables. There's only 1 variable on the first term. This is 2. What is the degree of this one? It's an divisible 1 on the variable. So this is degree 1. This is 0. This is 1. So what is the highest degree of this equation? The highest degree is 2. That's why it's a 2 variable equation, highest degree 2. Okay, let me show you non-examples. Copy these. Non-examples given are x squared. Another non-example is x squared plus 3x plus 2. And the last non-example is -3 plus x equals 10. As you're copying that, you should be thinking, these are not quadratic equations because, let's see, help us out. Alicia, why is this last one down here not a quadratic equation?
Because it doesn't have 2 variables.
It doesn't have 2 variables, that is correct. What else, guys? Aaron, why is this one also not a quadratic equation? Alicia said because it doesn't have 2 variables. That is true. What else?
It doesn't equal y.
Yeah, well, that would be the second variable. So it doesn't have 2 variables. What else?
Oh, it doesn't have a degree higher than 2.
That is correct. This degree is only 1. It doesn't have a degree of 2. Thank you. How about these top 2 right here? Kiana, why do you think these 2 right here are not quadratic equations?
Because it's not even an equation at all.
Because they're not equations. That is correct. These are only quadratic expressions or polynomials, whatever you want to call them. That is correct. All right, give me some hashtags. What makes a quadratic equation a quadratic equation? Give me one, please. Hector, hashtag what?
Hashtag quadratic equations.
Okay, quadratic. Okay, let's leave that on the side because we know that they are quadratic equations, but what would be something that makes them quadratic equations? Shakira, help them out. It's Ayana.
Two variables.
Two variables, that is correct. Two variables. Yep, that's one thing that makes it a quadratic equation. Something else, Juan?
Highest degree is 2.
Highest degree 2. Highest degree 2. And one more. Chloe, what would be the last thing that you would write?
Hashtag always equation.
Always equation. Always equations. Thank you. Yeah, so basically that's what makes quadratic equations quadratic equations. They have to be two variables, highest degree 2, and they need to be equations. So pretty good. Man, you guys remind me of me in kindergarten. All right. All right, let's move on. Copy this one, example 1. Solve using square roots. X squared minus 49 equals y. Copy that. I'll give you some time, and I'll go over it. All right, writing utensils down, look up to the screen. So please, please stay focused. I'm going to go through the process. I want you guys to just pay attention, and then I'll ask you to copy right after. Here we go. So it says, solve using square roots. So that means we need to solve for a variable. Whenever we solve a quadratic equation, we don't solve for y, we actually solve for x. What do we solve for? X. So Mr. Q, so what do we do with y? Okay, so that's our first step. So here we go. Look up to the screen. My first step in solving any quadratic, we need to make y and substitute that for 0. Take y and substitute that for 0. Why, Mr. Q? Because that would make us focus just on the variable x. And you're just paying attention right now. You'll copy right after. Focus, please. Next, I still need to solve this, okay? So that means I'm going to use inverse operation. I'm going to leave x squared by itself. So I need to get rid of negative 49. How do I do that? Plus 49 plus 49. That leaves me with x squared equals 49. Now, this is called solve by using square roots because in order for me to cancel this square at the end, I need to take the square root. A square root cancels a square. Well, whatever I do to one side, I do to the other. So that means x equals, pay attention to this one, plus minus 7. Why plus minus 7, Mr. Q? Well, square root means what number times itself gives us 49? 7 times 7. What other number? Negative 7 times negative 7 give me 49. This is your answer. Copy that, please. All right. So here goes the process one more time. To solve a quadratic equation using square roots, what do I do first? I need to make sure the y is what? 0. Next step, I need to leave the x squared by itself by using the inverse operation. So what do I do to the negative 49? I add 49 to each side. Now that I have the x squared by itself to cancel the squared, what cancels the squared? A square root. That's why this is called solving by square roots. Take the square root of both sides. We're left with x on one side. What is square root of 49? Plus minus 7. Because plus, it's 7 times 7 is 49, or negative 7 times negative 7, 49. All right, show me your fingers. How come you are with this? 1 through 5, 5, 5, 5. Yeah, I'm going to give you one for you to do by yourself. Copy this next one. Example 1Q. You don't have to copy the instructions. It's the same instruction to solve using square roots. X squared minus 64 equals y. Copy that and go. All right, let's see if we got it. Solving by square roots, what's the first thing? We need to make sure that y is what? 0. So we're left with x squared minus 64. Next, I need to solve, isolate the x. How do I do that? What is How do we cancel this negative 64? Add 64 to each side. We're left with x squared equals 64. And now that we have x squared by itself, to cancel that squared, we need to take the square root. That cancels the squared. Whatever we do to one side, we do to the other. This cancels that. X equals plus minus 8. Hands, have you got that? All right, good. Let's go. Example 1 megacube. Copy this one. Same instructions. You don't have to copy the instructions again. It says solve using square roots, and we are given 3x squared minus 27 equals y. All right, let's solve this one together. Same process. All right. What do I do first? Vanessa.
Make the y 0.
Make the y 0. So we're left with 3x squared minus 27 equals 0. Next step. What do I write? Kevin, tell me what to do.
Add 27.
Add 27 to each side. Thank you. We end up with 3x squared equals 27. Let's see, help us out. Mel, what do I do next?
You divide 3 x.
Yeah, divide by 3 both sides. That is correct. X squared equals 9. Next step, Vanya.
You square root both sides.
Square root both sides. This cancels that. X equals plus minus 3. Woo. Show me a famous shot come to your with these. 5, 5, 5, 5s. Yeah, these are nice, right? Okay, here goes another one. Very much like it. You do this next one by yourself. Example 1 super Q. We got 4x squared minus 100 equals y. Copy that and solve. Go. All right. Let's see. Ruben, what do I do first?
You simplify 4x squared
Okay, how do I do that?
by taking the square root.
Close. Step 1.
You rearrange the equation.
No, you're skipping steps. Jeremiah, help him out.
You put it to 0. You put y is 0.
So the y becomes 0. Make sure you make a note of that, guys. 4x squared minus 100. All right, now that we have that to 0, next step, Julian.
You add 100.
Add 100. Add 100. So basically, we're leaving x by itself. So we end up with 4x squared equals 100. Itzayana, next.
You divide 4 by both sides.
Divide 4 to both sides. We end up with x squared equals 25. And I'll do the last step. Take the square root, x equals plus minus 5. Hands, have you got that? Let's go, okay? So once again, this is our solution because we're solving for x. Are we solving for y? No. Solving for x, okay? But once again, what's the most important part, I guess, from the beginning is making sure that y is 0 in order for us to solve for x. Okay, let's move on. Example 1 super duper Q. Let's do this one more. We got 4x squared minus 16 equals y. Last one of these. 4x squared minus 16 equals y. Copy that and go. See if you can go a little bit faster now. All right. Let's see. I'm going to pick someone to do this whole thing. Let's see. How about Jerry? Go. What do I do?
Make the y into 0.
To make the y into 0, so we got 4x squared minus 16. Continue.
Add the 16 to the other side.
Add 16 to both sides. We end up with 4x squared equals 16.
Give me a second.
1.
You divide by 4?
Divide by 4, divide by 4. Yes, because we need to get rid of this 4 that's multiplying. So we end up with x squared equals 4. And then?
Square root.
Square root, square root. X equals plus minus 2. Hands if you got that? Yeah. And once again, what method is this called? Solving using square roots. Okay, make sure you make a note out of that. Thank you, Jerry. Move on. All right. Let's see. Same process, same process. Okay. So look at this one. Don't copy this one. Example 1, Michael Jordan Q. Look at it. What do you guys notice on this one?
That it's already 0.
It's already 0. So from here, we do what? Minus 9 minus 9. Negative 9x squared equals negative 9. And then we do divide by negative 9. X squared equals 1. And then the last thing is square root, x equals plus minus 1. Yeah? So the process is still the same. It might look a little different, but the process, if you follow it, it's the same. All right. Copy this one. Example 2. Solve by factoring. Solve by factoring. Copy the instructions, please. Example 2. Solve by factoring. Solve by factoring. Example 2 is solve by factoring, and it reads x squared minus 9 equals y. X squared minus 9 equals y. X squared minus 9 equals y. All right? Writing utensils down, look up to the screen. Here he goes. All right. Focus, please. You all ready? All right. It says solve by factoring. So in regards to factoring, we know some of the processes, but before we get started, what is the one thing I asked you to do when solving quadratic equations? Making y what? 0. That doesn't change for any method. There it is. Okay, next. Look at this. Can we factor this? You're like, oh yeah, we've been working with these, Mr. Q. Yes. Is this in standard form? Yes. Is there a GCF other than 1? No. So what was the other method that I showed you guys, a shortcut to factor this? Who remembers? Susana? What was a shortcut?
I'm sorry, what was the question again?
What was a shortcut to factor this binomial? It's known as a difference of squares. You guys remember that? All right. Julian, do you remember? Thank you, Susana. Julian, do you remember how to factor this? Okay. All right, look up, guys. Does this look familiar? Yes, that's the shortcut. If we can take the square root, let's see if we can take the square root of x squared. What two numbers multiply give me x squared? X times x. Okay. What two numbers multiply give me 9? 3 times 3. So if these are squares, which we just proved that they are, if this is subtraction, which it is, and it's a binomial, then this is a difference of squares. That this is plus and this is minus, and all that equal to 0. So what does that mean, Mr. Q? That this times that equal to 0. And we've been doing these with the excluded values, right? Is that correct? So what would I do next? I would write x plus 3 equal to 0, x minus 3 equal to 0, and I solve. Let's see. Minus 3, x equals -3, plus 3, x equals 3. This is called solving by factoring, but this is a binomial. It's a difference of squares. That's why we use the square root shortcut right here. Copy that, please. All right, here goes the process one more time. Solving by factoring. I need to make sure it's equal to 0, changing the y to 0. And since it's a difference of squares, I did the little shortcut, square root, square root. It was for both. One is positive, one is negative. Set each factor equal to 0 and solve. So we referring to with this kind. 5, 5, 5, 5. Okay, let's see if you can do one by yourself. Copy this next one. Example 2Q. We got x squared minus 64 equals y. And solve by factoring. Go. All right, let's see how we did. So first thing we do, guys, set y equal to what? 0. We got x squared minus 64. We're solving by factoring. What kind of polynomial is this? It's a difference of squares. Let's check and see if it's true. Square root of x squared is x and x. Square root of 64 is 8 and 8. If it's a subtraction here, it's a difference. So that means this is plus, minus. All that equal to 0. From there, we set each factor equal to 0. X plus 8 equal to 0. X minus 8 equal to 0. And we solve. Minus 8, x equals -8. Plus 8, x equals 8. All right? These are my solutions. Now, I'm going to give you some names that we're going to be using now for Algebra 2, since we're getting close to the graphing portion. These are known as solutions, also known as roots. Why do you think they're roots? Think about it. Yeah? Okay. They're also known as zeros. Why do you think they're called zeros? Because at the end we do what? Set them equal to 0. And the last name, they're known as X-Intercepts. Why do you think they're called X-Intercepts? Because when we get to graphing, guess what? Those are the X-Intercepts. All right? Let's move on. Copy this one, example 2 super Q. Solve by factoring. Let's do this one together. We are given 2x squared minus 50 equals y. 2x squared minus 50 equals y. All right? Help me with this one, McKenna. What is the first thing I do?
Set it equal to 0.
Set it equal to 0. So we got 2x squared minus 50 equal to 0. So now we're doing what? Factoring, okay? So what can I do here? Let's see, Jeremiah, look at it. What can I do here?
You can add 50 to both sides.
Okay, that's a different process. That's solving by square roots. Right now we're factoring. How can we factor this right here?
Oh, square root 2x squared and 50.
Yeah, but we can't because the 2's not a perfect square. So it's in standard form. Here it goes. I'm going to help you with this step. It's in standard form. What is the next thing that we usually check to see if it has what? GCF. Is there a GCF, guys? Yes, it's 2. And we're left with x squared minus 25. All that equal to 0. Can we factor the one inside of the parentheses, x squared minus 25? Yeah, Tony, what do I do for that, for this piece?
Square root.
Yeah, take the square root. We get x, 5, it's a subtraction, so plus, minus. Bring down the 2, equal to 0. Next, what do I do? Rachel.
Then you equal it to 0.
Put them equal to 0. So x minus 5 equal to 0, x plus 5 equal to 0, and 2 equal to 0, because now we have 3 different factors. Is 2 equal to 0? No. We eliminate that. Solve for the other. Minus 5, x equals negative 5, plus 5, x equals 5. These are my what? Solutions. What else? Roots. What else? Zeros. And what else? X-intercepts. All right. Show me if you're come to you are with solving by by factoring these kind that are binomials. Okay, 5, 5, 5, 5. Okay. All right. So we're good up to right there. So we did solving by square roots where we needed to leave x squared by itself. We did these kind, which is factoring, which is difference of squares. We use difference. But what if it wasn't like that? Look at this one. Example 2, Shazam Q. Copy this one. It says solve by factoring. 5x squared equals 20. All right, what is the first step that we said that y has to be 0, but there's no y. Instead of y, what is there? A 20, right? Wasn't y supposed to be here? Yes, so how do we make this 20 to be 0? Yeah, subtract 20 to each side. We end up with 5x squared minus 20 equal to 0. Look at the this part. Is in standard form, yes. Can we check for GCF? Yes, 5, we're left with x squared minus 4 equal to 0. Next, square root, we end up with x plus 2, x minus 2, and 5, and all that equal to 0. And last but not least, set each one equal to 0, yes? 5 equal to 0, x plus 2 equal to 0, x minus 2 equal to 0. This is not true. Minus 2, x equals negative 2, plus 2, x equals 2. And we're done. Yeah? So once again, you got to remember that one of the sides has to be equal to 0. So if it's not equal to 0 and there is no y, so you need to take that one and send it to the other side. Okay? All right. Enough of the silly games. Copy this one. Factor, solve by factoring. 2x squared plus 5x plus 3 equals y. You're like, oh, snap, Mr. Q. I know, right? Let's go. Solve by factoring. Example 2, Star Wars Q is 2x squared plus 5x plus 3 equals y. All right, here we go. Everyone, first step, we need to change y to what? 0. That is correct. And we're left with 2x squared plus 5x plus 3. All right, next, we need to factor this. How do we factor this? Well, it's in standard form. Is there a GCF other than 1? No. So what do we use to factor that? How do we factor this, guys? Let's see. Now, somebody didn't remember earlier what goes on top. Kiana.
6.
Bam, Kiana, let's go. 6 underneath 5. What factors of 6 add up to 5? 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. Yes. So we need to rewrite this 2x squared. And then instead of 5x, we're going to use these. So we get plus 2x plus 3x. Then you bring down this one, plus 3. Let's group. We got 2x, and we're left with x plus 1, plus GCF here is 3. We're left with x plus 1. So what are my factors? What is the same here and here? X plus 1 and 2x plus 3. And all that equal to what? Yeah, 0. So what do I do then? Same process, set each one equal to 0. X plus 1 equal to 0. 2x plus 3 equal to 0. And we solve. Minus 1, x equals negative 1. Minus 3, 2x equals negative 3. Divide by 2. X equals negative 3 over 2. Woo! Let's go. Have you been doing this? We've been doing this, right? So what's the only thing that we're adding at the end? Just setting each factor equal to 0 and solving. Okay? All right, let's go to the last part. Here we go. Now, if I was to give you another one of these, factoring a trinomial like this one, this is an easy one. Look at it. X squared plus 5x plus 6 equals y. You would know how to do that because you set it to 0, Power Rangers, and so on and so forth. Well, I want to get to this one. Look up, please. Solve by graphing. We got x squared minus 9 equals y. Ready? Okay, so to graph this, look up. I want you to get a table going. Yes, y. And first, we're going to substitute 0 for x. And then we're going to substitute y for 0. So, look up. If I substitute 0 here for x, what is 0 squared? 0. So that leaves us with what? Negative 9 equals y. So that goes right here, negative 9. Let me plot that. 0, negative 9. That's what we call the y-intercept. It's when x is 0. Next, I'm going to substitute y. Instead of y, I'm going to substitute 0. So that is 0 equals x squared minus 9. Okay, you're like, oh, now I see what we're doing, Mr. Q. Of course. Question. How many methods do we know how to solve this? We have 3 different ones. Which one do you want to use? The easiest one is by square roots, yeah? You're like, yeah, Mr. Q. All right, so then plus 9, x squared equals 9. And we do the square root, x equals plus minus 3. So here we have what? Plus 3 and minus 3 for the same 0. So what are these? They're right here. Plus 3 and 0, minus 3 and 0. And these are called the X-intercepts right here. All right, look up. And now we can graph. Anytime we're dealing with squares like this, the parabola, this is what we call it. It's like a happy face. It's a parabola. So that means it's going to look like that. Woo, let's go. Some of you are like, I think I'm remembering, Mr. Q. Yeah, you should be getting there. Now, tonight, I want to see the processes. Now, if you get stuck with the graphing, I don't mind that. But the other ones, you should be able to do. Solve by square roots, solve by factoring, right? And the difference of squares and the trinomials. All right, guys. So once again, that's our lesson for today. Let me show you the home play once again. Home play for tonight. It's only 6 problems. Make sure you go to your asynchronous code and get that from the Nearpod presentation. All right, guys. Enjoy your home play. Tutoring once again, 2 o'clock. See you guys later. Bye. Peace.